Okay, now we're starting a unit called trig applications. We'll get into all sorts of fun stuff, but the main difference between this unit that you'll notice compared to previous trig units, at least in my classes, is now we're starting to break out the calculators. And what that means is we're not going to focus on special angles so much anymore, like 30, 45, and 60 degrees. We're going to just do any degrees, right? And we're going to have to use the calculator to determine what those things are. So I want to first point your attention to this. It's very important that your calculator is set to the correct mode. And by that, I mean either radians or degrees, right? You have to select the one that's appropriate for the problem you're working in. Most of the time in this unit, we'll be working in degrees, so I'm going to leave this calculator set in degrees. And whether your calculator looks like a TI-84 or a less fancy version, it really doesn't matter. Every calculator has a mode button, okay? Right, let's use my pen. Right here is your mode button, and that's how you get into degrees and radians settings, among a number of other things, but we won't talk about those for now. And the big important buttons that we're going to be using are these guys: sine, cosine, and tangents, and the inverse sine, cosine, and tangents. So if you see, I mean, the sine, cosine, tangents are obvious. If you see that little blue print above it, right in there, that's where the inverse trig functions live. So the way you get to that is using this second button, and then you hit sine. So if you want inverse sine, you say second sine. If you want arc cosine, you say second cosine, and so on. Okay, so we've got a problem here that says use your calculator to evaluate the angle theta equals the inverse sine or the arc sine of 8/9. So all I do for this guy is, I know a lot of people are going to love this, you just type it into the calculator, and that does the work for you. So you say arc sine or inverse sine of 8/9, you type it in just like I've got right here, and that's going to spit out an answer for you. And, well, I actually shut down my calculator, so hold on, let me get that. Inverse sine of 8 divided by 9, and I typed it wrong because I'm having a old person moment here. Okay, here we go. So, inverse sine of 8/9, try again, Murphy. Okay, so I get this. Theta equals, and the calculator just spit out 62.73395, and so on. Now, this answer needs to be written to one decimal place using degree units. We've already got the degrees covered, but just a review of rounding. When you're rounding things, one decimal place means this guy right here. So 0.73 rounds down to 0.7. I can just say 62.7. Although if you entered the whole big thing in the calculator, you would still get marked right. It's not going to mark you wrong if you said 62.73 for your answer right here, okay? 62.73. If you put that down, you'll still be marked correct. What this means right here when it says use decimal places is it means you have to have a certain degree of accuracy. Now, if your answer is more accurate, fine. But if you rounded your answer to 63 degrees, which would be the nearest integer, you would be marked wrong because it was not accurate enough to satisfy the requirement here of one decimal place. Okay, so there's your basic intro. We'll have lots more problems coming up.